Prove that the following basic identity is true. That sine squared x plus cosine squared x equals 1. This is known as the Pythagorean identity, and it's a fact that we know is true, but we're going to show that it is true. Proof. The sine x by definition is equal to opposite over the hypotenuse, and the cosine x by definition is the adjacent over the hypotenuse. Step 2. Sine squared x plus cosine squared x is therefore equal to the opposite over the hypotenuse squared plus the adjacent over the hypotenuse squared. And then if we square both of those, we'll have the opposite squared over the hypotenuse squared plus the adjacent squared over the hypotenuse squared. And since they have a common denominator, we can add them together and get the opposite squared plus the adjacent squared, all divided by the hypotenuse squared. But according to the Pythagorean theorem, the opposite squared plus the adjacent squared is equal to the hypotenuse squared. So now we have hypotenuse squared divided by hypotenuse squared, or that would be equal to 1. Now we could have proved this with drawing a right triangle, putting A, B, C on there, but I just used the basic definition, and that's a good proof as well as the other one would be a good proof. Note, we will be using these basic identities to prove more general identities and to simplify trigonometric expressions. Identities are special equations or formulas that are true for all values for the variables, and these will be given to you on a formula sheet when you take the test. The basic definition identities will be.